Geometry lesson 3-4. Last time we were discussing some of the different relationships that parallel lines create in terms of corresponding angles and consecutive interior angles, alternate exterior or alternate interior angles. And we use those ideas when we're dealing with parallel lines, the relationships that are created. Now, if we reverse that, which we would consider to be called the converse, if we were looking at the converse of those scenarios and say, what would it require for those angles to be to force us to have parallel lines? So we're reversing the other way. Yes, the last time it was parallel lines create these relationships of the angles. Now we're saying the relationship of the angles we need to create parallel lines. So the corresponding angle converse, remember converse reverses the order. If two lines have a transversal and the corresponding angles are congruent, so corresponding angles are congruent, then the two lines must be parallel. What we mean is, if you actually look at a couple lines and you go, okay, there's that transversal. If this angle is actually the same as that angle, if we know that to be the case, if I've been told those two are equal, then these will be parallel. It forces them. They must be parallel. So before, we were using the parallel lines to say the angles were equal. Now we're using the angles to say the lines are parallel. So it's the reverse concept of that. Alright? Let's assume that we're all trying to, on each one of these, we're trying to prove that we are dealing with parallel lines. We're trying to prove parallel lines. So assume two lines are cut by a transversal each time. The result is that both lines are parallel if, and this is all converse of each one of our concepts before, the alternate interior angle converse, if the alternate interior angles are congruent, then you know the lines are going to be parallel. Just like we used parallel lines to prove that the alternate interior angles would be congruent, now we use the idea that they're congruent to prove the lines are parallel. We just reverse it, converse. Alright? The consecutive interior converse. If the consecutive interior angles are supplementary, meaning if the two add together to make 180, then you know the lines that they are inside are going to be parallel. And the alternate exterior converse, if the alternate exterior angles are congruent, then you know the lines you're dealing with are going to be parallel. Alright, first example, given this particular diagram, this angle 2x plus 1 is right here, and 3x minus 5 is right here. We'd call these alternate interior angles, because they are inside the two lines that are being cut by the transversal, and they're alternates because they're on opposite sides of the transversal. We need to decide what value for x would make these two lines, M and N, parallel. We want to know what's going to make them parallel. In order for them to be parallel, the alternate interior angles must be congruent. Therefore, 2x plus 1 has to equal 3x minus 5. And we just play the shuffling game from here. Subtract 2x, subtract 2x. 1 equals 1x plus negative 5. Add 5. And we have 6 is equal to x. Now that's not the angle. The angle measurement isn't 6. The value of x is 6. Let's try it. 2 times 6 is 12. And 12 plus 1 is 13. 3 times 6 is 18. And 18 minus 5 is also 13. So it works. If we stick 6 in there, we get something that's exactly the same here for both alternate interior angles. Because the alternate interior angles are congruent, the lines would have to be parallel. Alright, example number 2. You notice windshield wipers stop to make a 30-degree angle with the bottom of the windshield. If they were long enough, would they ever touch? Why or why not? Now I know there's different versions of windshield wipers out there. Sometimes there's even one windshield wiper. It just depends on the car. But for the most part, we'll go with the traditional look, which is somewhat similar to this right here. And we're imagining that they make a 30-degree angle. So we'd be saying that down here is 30 degrees, and down here is 30 degrees. Now this line right here, in essence, is acting as the transversal between those two. And we would say that this is a corresponding angle to this corresponding angle. And if the corresponding angles are congruent, just like our definition stated here, If you have two lines with a transversal and the corresponding angles are congruent, then the two lines must be parallel. And if these two lines are parallel, then they're not going to touch. Alright? Would they ever touch? The answer is no. They would not. Alright? Now, if they're not, if one's 30 and one's 29, then eventually, given the length, they would. Example number 3, here's the diagram. Quite a bit to this. You've noticed there's green lines, there's red lines, a bunch of angle measurements. There's quite a bit going on here. Our first question is AB parallel to DC? Now, AB is the green line here, and DC is the green line up there. If you can, what helps on these kind of problems is to sort of block out some of the other information. Now, we have these two green lines that we're wondering if they're parallel. If they were parallel, then this black line right here would be the transversal going through it. Imagine that. And if it is, you've got an interior angle here and an interior angle here that are exactly the same. Alternate interior angles are the same, since angle CDB equals 65 degrees and angle ABD equals 65 degrees, which are alternate interior angles, we would say yes, they are parallel. So I can label this, erase this stuff here, and I can put B to get taken out. Okay, so B is here, D is there. Now the next question we have, I can go ahead and label this parallel, parallel. Are BC and AD, the red lines, parallel? Now, if you look at this particular situation, you've got this parallel line here, or this line here, and we're curious that they're parallel. Those are the two lines being cut by this transversal. If that's the transversal, then this corner and this corner are supposed to correspond, and since one of them is 155 degrees and the other is 115 degrees, they don't match up, which means they are not congruent corresponding angles, so we would say no. 155 degrees does not equal 115 degrees, and we need corresponding congruent angles.